you've been given a piecewise function, and you've given a constant at the end, m, and m can equal various things. So we're going to graph this piecewise function as if f equals m equals -1. So, and this should be less than or equal to -1 and then greater than or equal to also -1. And so x squared minus 1 looks like this. It's a quadratic. We only want the part less than -1. So over 1 up 1, over 2 up 1, 2, 3, 4. It should really go through that point there. We're going to highlight the portion of this that we want. Everything less than -1. Everything else we will erase. And now we'll graph -x plus m, where m is -1. So this really is -x minus 1. So we'll go through this point, and we'll have a slope of -1. And so this point that was open circled before gets filled in because we're greater than or equal to -1. This would be the graph when m is -1. There are no gaps in the graph. That's true. If m equals -1, f decreases on the interval -infinity to infinity. That's true because we decrease the whole time. 1 is the absolute minimum. That's false. There is no absolute minimum because this goes on forever. The domain is all real numbers. That's true. Now we will draw a different function where m is 1. So we'll erase what we have here. Only the portion of the graph that is the line gets erased. The rest stays. So if m is 1, we have a y-intercept of 1 and still a slope of -1. So now, are there gaps in the graph? Yes, there's now a gap in the graph. So this would be false. Where's the gap? It's right here because we have to pick up our pencil to come up to there. Is the domain all real numbers? This is still true because we have an open circle here, but -1 is filled in there. The range is all real numbers. This is true because we go from infinity down to -infinity for y values. So that would be true. For any of these problems, though, the trick is to graph. Obviously, on your assessments, there won't be an error in the domain, but the trick is to graph over a domain, and there'll be two different sets of y functions for the domain.